Earlier this year, Queen Maxima helped open the first 3D printed stainless steel bridge in Amsterdam. The bridge is the brainchild of MX3D, a Dutch company that has developed a proprietary software to turn an ordinary welding robot into a high-end industrial 3D metal printer. Plans for this bridge began 6 years ago in 2015. MX3D proposed 3D printing a metal bridge on site. They developed several design concepts and got the support of Autodesk and the city of Amsterdam. After finding a location in the red light district, they scanned the site and created a highly detailed digital site model. The scan helped them develop design constraints like dimensions and strength of medieval canal walls, the limits of 3D printed steel, on-site assembly, city regulations, and engineering and practical limitations. MX3D teamed up with Joris Laarman, who is most famous for his bone chair design. This biomimetic design was inspired by human bones that develop the most mass in areas exposed to high stress. The chair is a volume-optimized structure that performs with the least amount of material. MX3D and Laarman tried to use the same volume optimization approach in the design of the bridge, but failed, so they teamed up with the engineers at Arup on a sheet construction approach. Stress analysis software generated force lines through the bridge. Since the bridge heads are not aligned, the shape had to be asymmetrical. They also had to scrap the idea of printing it on site because of safety and technical concerns. The eventual design that they came up with shows off the capabilities of 3D printed metal technology. They developed a software called Metal XL that calibrates materials, performs feasibility checks, slices the design, plans a toolpath, prints the object, monitors the process, and finally prints a report. They call this printing method Robotic Wire Arc Additive Manufacturing Technology, or WAM. A 6-axis robot and a MIG welding machine creates pieces by depositing metal layer by layer. Although this bridge was made of stainless steel, they can also print in carbon steel, duplex steel, aluminum, and bronze. Even though the walls of the bridge are thin and hollow, the overall shape makes it strong. The bridge measures 41 feet or 12.5 meters and weighs 9,920 pounds or 4,500 kilograms. The actual printing process took just 6 months and was completed in 2018. They had to wait almost 3 years to install it because of renovations to the canal's walls. When it was ready to be installed, the bridge was cut up into 3 parts and transported to the site on barges. The pieces were lifted by a crane and welded together on site. Scientists at the Alan Turing Institute, IoT specialists, and engineers embedded a sensor network in the bridge and created a digital twin. Data from these sensors serves multiple purposes. It helps them monitor changes to the bridge's health over time, understand how 3D printed steel behaves, collect structural measurements such as strain, displacement, and vibration, count the number of pedestrians that cross it, and even measure environmental factors such as air quality and temperature. The bridge is being taught to understand what is happening on it, like how many people are crossing it and how quickly. I looked into the origins of 3D printed steel. One of the earliest records of it is a patent filed by Ralph Baker in 1920. He described using an electric arc to deposit metal in layers to form various ornamental and useful articles like a water jug and a basket. To go from that initial idea to a full-size bridge is very impressive. Since they were the first to attempt this, they had to go through a lot of growing pains and failed designs. They also had to wait 6 years to see it finally installed. Now that's a labor of love. While the design itself isn't really biomimetic like the bone chair, it has a unique, futuristic language of its own. It's a statement, a piece of art, a hint at the future of 3D printed designs. I'm sure some people think that it sticks out like a sore thumb in the area, but I think it is so drastically different from the vernacular architecture of Amsterdam's red light district that it works. I love that they didn't paint the steel or powder coat it. They left it honest and raw. I haven't seen the bridge in person yet, but from photos it looks like the metal reflects the color of the sky during the day and the red lights at night. It's transformative. Now the downsides. Just like with any outlandish Zaha Hadid or Gehry designs, there's always a question of why. This bridge is going to be in place for just 2 years while the original bridge is being restored. Why spend so much time and effort building this? It's a valid question, but this bridge pushes the limits of a new technology that has the potential to change the way we design and build. The team also claims that the bridge is hyper efficient and uses minimal materials. Robotics enables significant weight reduction and reduced impact for parts manufactured in the tooling, oil and gas, and construction industries. However, architect Philip Oldfield calculated that the steel used in this bridge has 27.7 tons of embodied carbon. Nicholas, who is part of our YouTube community, recently visited the Netherlands and experienced this 3D printed bridge. He left me some very personal and helpful feedback. He said that the layered print and welding is crude and uneven. It's not as sleek as it appears to be in photos. He also said that the bridge does not take directionality of the layering into account in the way a concrete bridge does. The layers look arbitrary, which is an excellent observation. Nicholas's father created large aluminum sculptures back in the 1980s by casting them around blocks of styrofoam shaped with a hot wire. This method created smooth, polished surfaces in a much shorter time frame than 3D printed steel. Nicholas also said that the curved handrails are used as a trash can by people passing by. This is why humans can't have nice things. Lastly, there's a significant misalignment between one side of the bridge and the pavement. They try to fill the gap with brick pavers, but it looks very sloppy. It's definitely not wheelchair accessible on that side. Even though they had high-tech 3D scans of the site, they still couldn't fit it cleanly into the context. I think we need to understand that this bridge is an experiment. It's a rough first iteration in this exciting new technology. It may be more expensive and take longer to produce right now, but it has the potential to change the way we design and build in the future. If you've visited this bridge, let me know in the comments. Also, let me know what else we can use 3D printed steel for. I'll link my Patreon page in the description. If you can support me, I'd really appreciate it. A big thank you to everyone already supporting me. Don't forget to hit the like button and subscribe to my channel. Thanks for watching. See ya.